All right. So literally going to go through here, and I'm going to go through and just share the screen on this. All right, cool. So you can see my screen here. Yeah. Okay. Cool. All right. So I'm gonna pull in this. Actually, you know what? Go ahead. Can you unmute your stuff? I don't care if buzzes. I hear buzz in the background. I don't care about that.
Okay.
Is just weird to talk to like a blank screen there. So like it's more my stuff than your stuff. So okay, cool. So what I've got your data set open here. And then the Neyman or the Johnson-Neyman plot stuff going on. Okay, so I went through and tweaked this a little bit so that I'm actually running your regression model here. Okay, and what I do, because I was running this on my laptop, so what I'm going to do first is go to where I've got the Excel sheet where I'm saving your stuff. So LME JN XLS. So if I go left click or right click properties, can just steal that location. And so this was what I was running on my laptop. So I'm just gonna go laptop and then just give this a different for my desktop. And then so I'll just say, oops, putexcel set here, parentheses, and then making sure, and I think this is what you had missed before, making sure to specify the specific Excel sheet there at the end. So with writing the results into Excel, if I go through now and highlight this and say put Excel into, make sure that, okay, just wanted to make sure that that set wasn't open. So if I go through and run that, okay, looks like Stata ran that. So then when I go through and run anything, it'll send it directly to this file that I have tucked away in this folder. Okay. Did you ever figure out why your desktop wasn't doing that correctly?
No, I think maybe what might have happened is I have like 20 different versions of my data set based
Okay.
on different tweaks that I made.
Yeah.
So I think what might have happened is that the set I used to run all of this might have been in my downloads folder.
Okay.
I don't know if that would have made it impossible to export to a file that wasn't in the downloads folder, but it shouldn't have. So
Yeah.
I'm not quite sure what it was, but it worked on my laptop.
Okay.
And I was, as long as it works somewhere.
Okay. Cool. All right. So you've got this up, and so I'll just walk through how we would run this for your Titan by arousal interaction here. So here have your regression model, and I went through and modified this. So we've got your outcome condition 2 to 4. Did you know that you can do this in Stata? So that you don't have to, okay. So we got condition 2 to 4, all of your covariates, all of your first order effects, and then your interaction terms here. So if I go and I run that regression model, pops it up here, right? And now what I'm going to do is I'm going to go through and I'm going to run putexcel etable, which should transport that into your Excel file. So if we go through and pull that up, yeah, looks like I had some other stuff in there, but yeah, it looks like it's gone through and moved all that there, right? So we know it's working. It's writing your regression table in there, so I'm going to delete that, save, and then close this out. I'll just go through and pop this over into this other screen here. Okay, so now what I'm going to do, now I was going through and thinking about this. So what we've done is because we're running this on centered variables, and so what it's going to give us is values for the centered value, but for your plot, it would be nice to actually have raw scale, you know? And so if we go through and take a look and run your descriptives here, see that you've got, so for Titan, your standard deviation here is 2.372 or what have you, right? And we had talked about running this and running your graph from 2 standard deviations below to 2 standard deviations above the mean, right? But if I go through, so I can go display, take your standard deviation, paste it in there, times 2. So I get that, right? So what I had done is just took that standard deviation estimate there and plotted it into your margins here. So I've got, negative, or 4.744, blah, 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 whatever, to negative 7.4. And so I just pasted that into here. But the problem is, if we think about this, so if I go through, and I just summarize Titan, like your raw variable, looks like your mean is about 5.5. And so if I go display this, and then I add 2 standard deviations, which is this, right? I get a value of 10, but that, and so that exceeds the max value of your scale, right? So if we run a graph going from 2 standard deviations above and 2 standard deviations below, what we end up with is a value for Titans that isn't really a real value for your data, right? Same thing if we go display minus this, that ends up as a value 0.7. So but if your scale runs from 0 to 9, 2 standard deviations above, you don't actually get that level. So what I'm going to do is I'm going to go through and crepes. So what I want to do is I want to run this from the low end of your scale to the high end of your scale. And so your min max is 0 to 9. So if I go through and I look at on your centered variable, your minimum value to your max value, are you following me?
Mm-hmm.
So if I run through and if I take your minimum value and plug it in for your minimum value in this and your max value and plug it in there, what that's going to do is that's going to run this. So in your raw scale goes from 0 to 9, right? And so you've got a case in your data that has a score of 0 on Titans all the way up to a max value of 9. In your centered variable, that 0 and 9 is going to correspond to negative 5 point whatever to this. So I'm just taking those, dropping those into your margins command. And what that's going to do is it's going to give you a graph for the full range of your moderator. You following me on that?
Yeah.
So if we had a variable that had sort of a lot of sort of breadth in the scale, 2 standard deviations above and below would be pretty good, right? But because with this, if we go 2 standard deviations above, we break the top of your scale, right? And so what we don't want to do is create a graph that is graphing your conditional effect all the way up past a level that you can't actually score on the moderator. So we're just trying to keep things in bounds. Does that make sense?
Yeah.
Okay.
So we're no longer using the standard deviation metric. We're using the minimum and maximum values of the centered Titan variables.
Yeah, because we're using centered variables here, right? And what we're going to do is eventually convert on your graph that back to actual values for Titan. But because your model that we're running these for corresponds to your centered values, this is going to be the absolute minimum of your scale. in centered values, and this is going to be the absolute maximum of your scale in centered values. Does that make some sense?
Yep.
Cool. All right. So we've gone through, and we'll just run that regression model here. So there we got our regression model. And then I'm going to run your margins command, right? So you got your margins, and here's your conditional effect. So you're looking at wanting the slope of arousal on interpersonal functioning at centered titans from the minimum value of titans to the maximum value of titans. So if we go through and we run this, gives us a whole lot of values, right? But then if we go through, we say putexcel, e-table, looks like that went through and wrote that. So now I can go through and I'm just pulling this up. Oh, dumb. Okay.
Was it open?
Nope. Okay, there we go. All right. So here we've got your output, okay, from your minimum value. Is that? Oh, yep. So if we go through and want to take a quick look here. So we're running from the minimum value of negative 5.433, right, which is what we wanted, to 3.567, right? And so value at 1, value at 2, value at 3, that's just corresponding to this up there. So that looks like it worked all right. So what I'm going to do is I'm going to just copy all of this. Let me expand this out. So I'm going to copy that into a new page here. And so I want, these are my simple slopes, right? I don't care about my standard error, my t-test, or my p-values here. So I'm going to get rid of those. But what I do want is my simple slope and my interval. Okay, so I'm going to go through and cut this down. But then what I'm going to do here is I'm going to say, okay, actually, I know that this is equal to a value of 0 in my set. And so if I go, and I can call this 0, right? Because I know that this first value corresponds to a score of 0 on my set, right? And so I should then be able to go, so 0 for A1, and then in A2 I can hit equals A1 plus 0.05, because we've told this to increase in our syntax file. We told it to give us values for every 0.05 of our of the moderator, right? And so if I go here, that's 0.05. But then what I can do, so I've got 0, cell A2 is A1 plus 0.05. If I go down through and I start pulling this down, I see that it's increasing at 0.05 levels. And so if I run this all the way down, I should finish up with a value of 9, which is the maximized scale, right? Cool. And so what I'm going to do is I'm going to go through, we'll leave that. So now I've got, for the full range of my scale, from values 0 to 9, I have a simple slope and then an interval estimate here. Okay, follow me up to this point?
Yep.
Okay. And then what I'm going to do, because I want to have in my graph, I want it to plot a reference line at 0, because 0 is going to be sort of null effects, right? So that's what I want. I want to have a clear line at 0 running across. So I'm just going to go through and take 0 and paste that down. Okay. All right. So if I now go through and I go grab all this, go to insert, go to graph, I get a graph here that is doing generally what I want it to do. Okay, so we've got a chart title and a legend. I'm going to get rid of the legend here. So I'm going to, okay. All right. So now what I want to do, first thing I want to do is that axis at the 0 line is not convenient. So I'm going to double click on the y-axis here. Okay. And then if I go through and take a look at my options, it says horizontal axis crosses, I'm going to say axis value. I don't want it, I'm just going to put -4 because that's going to put it down there. It's the bottom of the graph. And so that's going to be good there, right? And then if I'm looking at my y-axis, okay, -4 to 2 works all right. I'm going to go through, I'm going to hit tick marks. I'll say minor inside. So I've got kind of little tick marks in there. I just kind of like that the way it looks. Okay. So that's looking okay. But now, if we notice, my x-axis runs from 1 to 184. That's not useful because that doesn't actually correspond to what my actual axis value is looking like, right? But what I did is in this A column here is I put in values for the actual scale. So if you go down and you click on the x-axis here, and you right-click and you go to select data, if I do that, this will pop up, right? And what I'm going to do is I'm going to go to horizontal axis, right? So this is my horizontal axis, my x-axis. I'm going to hit edit, and it's going to give you, it's going to ask the label axis range. And so what I'm going to do is I'm going to go to my A column here, here. Let me cancel this real quick. I don't want that. I don't want anything highlighted here. So, okay, I'm going to go back, I'm going to go select data, edit my horizontal axis, and it says axis label range. I'm going to take from A1 all the way down to the end. And I'm going to hit OK. And I'm going to hit OK again. And now if I go back up, we'll see that my axis now runs from 0 to 9. Okay. Now this isn't super helpful. So what I'm going to do now, I can go and click on this, my horizontal axis here is a format axis. And I'm going to go through, I'm going to ask for tick marks. I'll say minor inside. That gives me some tick marks there. Numbers. I want this to be general numbers to 2 decimal places. Works. Okay. And then this is still kind of tight in terms of what the actual values are. So what I'm going to do is I'm going to go through and say interval between marks. Let's see what happens if I turn this, set this to 2. Okay, what if I go 5? That's a little bit better. What if I go 10? Oh, whoops. That's just getting my tick marks. Let's see. We'll go 1 there. Okay. Trying to figure out. Oh, here we go. So if we go labels, specify interval. Let me go 5. That's still not great. Go 10. That looks pretty good. You like that?
Yeah.
Okay, cool.
And nice.
Yeah, okay. So, there we go. So we've got that. And now, I'm going to go through and start changing some of these settings here. So I'm going to double click on this reference line. And I'm going to make that like a dark red. And I'm going to change the weight of that down to 1.5 or 1.25. That works good for me, right? And then maybe for this, I'm going to turn that black and then make that maybe a lighter. Maybe we'll go 0.75 and make this dashed. And then maybe do the same thing for this. Let's try 1 and give it a long dash. Make it black. Yeah, I like that better. So I'm going to go 1, long dash. It's black. Okay. All right, and then maybe I'll go here and make this a solid black line. 1.25. Okay. I don't know. How do we like that?
I think it looks neat, but I'm not quite sure what those lines represent.
Okay, cool. We'll talk about that in a moment. Okay. And then I'll click out of this. And then I'm just going to steal this from your other thing here. So we'll put that title. And then if I click here and hit add, I want an axis title. So if I click axis titles, and now I can put or whoops, nope, this isn't. This is conditional effect of PCL arousal. Is that right?
Yes.
Yeah. That's your conditional effect here. So we got conditional effect of PTSD arousal. And this is your empathy tightens, right? Go through and bold that. Okay. And then that looks pretty good to me in terms of a model here. Yeah. Here, let's do this. We'll go through just to we'll make those dark blue for no reason other than I want to. So, okay, cool. So, what we have here is with these plots, instead of just having like our simple slopes, right, where we have simple slope at a standard deviation above and below, right, which shows us the relation between our outcome and our conditional variable at high and low levels of our moderator, right? Here, instead, what we've got is in this column, what it's doing is it's plotting this y-axis is giving us the simple slope from 0. This is giving us the simple slope of PCL arousal on interpersonal functioning from 0 empathy to a value of 9 at every single 0.5 intervals, right? So instead of plotting two simple slopes, what we've done is we've got a plot of 181 simple slopes here, okay? Now that would be too much to sort of graph the actual thing. So what we do here is if this x-axis is our moderator, right, your empathy variable, ranging from the 0, the minimum value, to 9, the maximum value. And your y-axis, this is your conditional effect of PCL arousal on your outcome, okay? And so what's nice about this is instead of just saying, oh, we have evidence for an effect of arousal on interpersonal functioning at a standard deviation, a standard deviation below, and a standard deviation above, what we've got here is we've plotted your simple slope across the continuous range of your moderator, okay? And so, and then these lines here are going to be your confidence intervals. So these are the confidence intervals around your simple slope at any given point in time, okay? So at low levels, at 0, how many people scored 0 on empathy for your Titans in your actual set?
Sorry, can you repeat the question?
Yeah, so how many of your participants actually gave an empathy value of 0?
0.
Yeah, well, someone did. At least one person did because it was the minimum of your scale, right?
Oh, right.
But not very many, right? And so because not very many people did, it's kind of at the end of your scale, you've got a pretty wide confidence interval, right? So for, let's say, based on your model, you're expecting that for people who who score 0 on your empathy measure, the unique effect of PCL arousal on interpersonal functioning is it has a coefficient of negative 2.44. Okay, but the confidence interval around that actual value, your data would support any population estimate ranging from negative 3.6 to about negative 1.3. All right, but is 0 a plausible estimate for your simple slope of PCL arousal on interpersonal functioning for scores of 0?
Yes.
Well, no, is based on your intervals, is your conditional effect of PCL arousal on interpersonal functioning at empathy equals 0, is 0 contained within these bounds? Nope, 0 is way up here, right? And so what's cool is with this plot is it's saying that based on your model, based on the data that you have, the conditional effect of arousal on interpersonal functioning, your data support non-zero values all until we get to where? About right here, right? And then once we get past, we can scroll down and see, right, if we're just looking at your confidence intervals here. Let me see, we should see upper limits start to cross 0 at about 6.5. Yeah. So you see right here, Layla. So at a value of 6.75, which is not a real value, but about somewhere between 6.5 and 7 on your empathy measure, you still have the conditional effect of arousal on interpersonal functioning still doesn't include 0. But once you get to 6.8, now the upper limit for that confidence interval is a positive number, right? And so what we've done is if we look up here, right about here, and this is about 6.75, now all of a sudden, in terms of traditional benchmarks of statistical significance, we would say that the unique effect of PCL arousal on interpersonal functioning, I can tell you exactly where, based on my model, all of a sudden 0 starts to become a reasonable estimate for this. Okay, So instead of our simple slopes, where we've just got a high and low value, right? What we've got here with this this Johnson-Neyman plot is a plot of your simple slope over the whole range of your moderator, and what we can do here is say roughly, and recognizing that this is just one model of many replications that could be done, but somewhere around 6.5, 7, we stop seeing evidence or detecting evidence of a unique effect of arousal on interpersonal functioning at very high levels of empathy. Okay? And so what's cool about this is what we can do is we can start saying not just, is this, do we have an effect of do I have a conditional effect at high and low levels of my moderator? I can start to get more nuanced detail and information about exactly where we stop seeing an effect of X on Y for my moderator. Okay? So based on this plot, right, if I'm looking at if I go back to sum on Titan, right? So this is your descriptive statistics for your moderator, right? So your mean value is about 5.5, right? So where does 5.5 end up on your scale? About right here, right? So for the mean and below, looks like pretty clearly you have an evidence for an effect of as arousal levels increase, we see a decrease in interpersonal functioning. But we don't get too far above the mean, right? About 1.5 points, 1.75. If we get too far above the mean in terms of empathy, then we start seeing that we no longer have evidence of a conditional effect of arousal on interpersonal functioning, because then my confidence intervals start to contain this 0 point. Okay? Any questions on this? Does this make some sense?
It does. So you would definitely want to do your simple slopes first to have a sense for what that relationship looks like, and then you'll be able to better interpret the Johnson-Neyman plot?
Well, actually, we really don't need your simple slopes, right? Because what this is telling you, simple slopes, if we were to look at your simple slopes have you're getting a negative simple slope of arousal on interpersonal functioning until we get to a value of till we get a value of about 6.75, right? And so really the issue with my simple slopes and the argument for why simple slopes aren't useful the way we do it is sometimes people will call this a pick-a-point method. So we just pick a standard deviation and run your simple slopes a standard deviation below and a standard deviation above, right? But is there anything really special about a standard deviation below a standard deviation above? No, right? We could pick a half a standard deviation or 3/4 of a standard deviation or 2 standard deviations or 3. That starts to get a little out of control, right? But the concern is that your simple slopes plot doesn't provide actually all that much information. It just says at these two very, very specific values for your moderator, what's the relation between X and Y? Okay. What we get with this is, and the way we've plotted it here, is we have not just the conditional effect of arousal on interpersonal functioning just at 2 specific points on a continuous scale. We have the value of your simple slopes across the whole range, right? And so what we can do is we can say specifically where on this graph where we stop seeing a unique effect of arousal on interpersonal functioning, and it looks like it happens right here between 6.5 and 7 points. Okay, and so with your, did you create simple slopes graphs for yours?
I did.
Do you, uh, yeah, I'm going to stop sharing. Okay. Let's see if I can. Okay, here, I'll make you the co-host of our meeting. All right, can you now share? Do you have your simple slopes up?
Yeah.
Yeah. Can you share?
I can.
Okay, perfect. Cool. So if we look at your simple slopes, right, what we've got is your simple slopes at low levels at height, and this is a standard deviation below, right? And so we're seeing this negative slope at a standard deviation below, right? And then we're seeing not much of a slope at a standard deviation above, right? So what this is giving us is the slope of interpersonal functioning and arousal at low levels of empathy and high levels of empathy. And so tell me what we're seeing in this simple slopes.
We're seeing that for folks who scored low on Titan, that the greater their PCL arousal reactivity scores, the lower their interpersonal functioning
Yep.
is. Whereas for folks who scored really high on the Titan, we're not seeing as strong of a decline.
Yeah, right? So if I go through and I take that and then I go back to what we've got here, right? What we're looking at here is specifically at low levels. What's a standard deviation below? Again, if I go back here, if I go...
For Titan, I think it's 2.37.
2.37?
Yeah.
Okay, yeah, but I want it in raw scale. So I'm going to go display mean minus... Oh, here. I'll show you what I'm doing. Okay, so if I go display my mean minus your standard deviation, that's so a value of about 3, and then a standard deviation above is a value of about 8. Okay, so if I go back to, so your simple slopes, okay, pull up share yours again. Okay, so your simple slope. So this is the simple slope of Titans when the empathy value was about 3.
Yes.
Okay, and then this simple slope corresponds to the relation between arousal and interpersonal functioning when empathy is about 8, right? Yeah. So if we stop that and if we go back to here, what we're seeing with the Neyman-Johnson plot is so right at 3, like this is somewhere right in here is the specific simple slope that you've plotted, and it's negative 1 point something, right? Well, actually, we can actually go down through and take a look. So let's say for 3, the simple slope is negative 1.6. with a lower end on the estimate, population estimate of negative 2.3, upper end value is about 1, right? So this was the simple slope that we saw in just one plot. And then at values of 8, this is the value we saw here, right? So a much less value. At values of 8, our simple slope is going to be negative 0.29 with a lower estimate of 1 and upper estimate of 0.5, right? So does this meet benchmarks for statistical significance? Nope, because it contains 0. Does 3 contain it? Would that be traditionally considered a significant simple slope?
Yes.
Yep, right? So, but the criticism of that simple slope method that we generally do is that it's just showing you the conditional effect of x on y at just 2 very specific points, right? The benefit of this and why this is cool is it's showing us your value of your simple slope. So basically, you can call this conditional effect, or you can just call this simple slope of x on y, okay? So across this full range, until we get to about somewhere between 6.5 and 7, your simple slope of x on y meets traditional benchmarks for interpretation, right? But once we cross over into 7 and above, then it's not anymore, right? And so what we're doing with this plot is it's giving you much more information than just the 2 lines. The 2 lines are a little bit easier. You kind of see, okay, that one's decreasing and then this one's kind of flat. But if we're thinking about wanting to actually explore and understand this phenomenon, this plot gives you a whole lot more information, because it not only tells you, at least, now again, this isn't like the population estimates. These are just estimates based on your sample, right? So we're not going to be like, oh, exactly this is the point at which this no longer has an effect. But what we can do is say, well, for people who score below the mean on empathy, we're seeing a pretty clear evidence for an inverse relation between arousal and interpersonal functioning, so that when people are scoring about a mean of empathy or below, we're really seeing evidence for, as arousal symptoms increase, interpersonal functioning decreases. But once we get too far above the mean, we really kind of stop seeing that association become as prominent. So we're really not seeing a unique effect of arousal on interpersonal functioning for people who are scoring about 1.5 points, 0.75 above the mean. Once we get to that point, then it looks like we don't have good evidence of arousal reactivity having a unique effect or a unique relation with interpersonal functioning once we kind of get above that level. And with our traditional simple slopes, it's kind of hard to tell exactly where that transition happens, right? And so this is just giving us much more information about sort of what's going on.
That makes sense.
Does that make some sense? Cool. All right. So now you've got a couple of different effects that are kind of just borderline in terms of interaction with your RMET, correct?
Yes. I was going to ask you if you got the chance to look at the intrusions.
Yeah, I think those are probably. I mean, I think you probably got something weird going on in your data. But if we're going to interpret one, you probably ought to interpret all of them. And so, yeah, we'll just go through and interpret it and sort of present the data. Because we don't want to just cherry pick the effects that work the way we want them to and then not interpret the other ones. Okay. So in terms of setting up these plots and sort of how to go through and particularly get this scale, are you feeling comfortable with that?
Yes.
Okay, cool. So we'll go ahead and call this, you and I can stay on. I'm going to shut the recording down for the purposes of setting that up. But if we have any other questions, we can get to that. Does that sound good?
Yeah.
Okay, cool. Yeah, no, I think this is a nice demo. This will be helpful as we sort of have other people working through this stuff. Cool. All right.